All right, in today's lesson we're going to look at polynomial functions. This is going to be a real brief introduction. So I sliced this first one up real small, so there's not a lot here to talk about. Before we get to that, they're going to just talk about a power function. So we'll see what a polynomial function is, but if you just have any x value that has an exponent and there's nothing else to the function except maybe a coefficient, so you just have an x and some power of any kind of power, then it's a power function. So you can do this in any term. Do you see that everything on this list is a power function? Because it could be written as an exponent. There's just an x, and you can, for instance, this could be x to the negative first. This could be x to the 1/3. Those are all exponents, so they're all can be just power functions. There's nothing but the x and an exponent. All right, so if you look across here, now they're trying to trick us here. These are not. There's a lot more going on than just a coefficient and an exponent. This one, however, could be simplified, and that would make it a power function. Okay, 8x to the 5th. Now here's what this section is really about. Polynomial functions, where we're going to have those power terms, but we're going to have a whole series of them. There's not going to be any denominators. We're just going to have this expression without any roots, anything fancy. It's just going to be a descending value of x's with different exponents. Okay, so if we were looking through here, what could be a polynomial function? We're going to simplify these first. So if we look at that, this is a polynomial function. All I have is some, we don't have to have all the terms. I have a coefficient and an x value with an exponent, and we have nothing else that contradicts it. If you look at g of x, this one has been rewritten too. That's okay. This is a polynomial function. Just have x's and exponents. But this is not. Because of the square root, there is no way to turn this into just this, where I just have some descending set of terms with just x. So basically a series of power functions added together. All right, now just some real basic terminology for this. So we have the coefficient is in front. The degree, you've probably seen before, is the highest exponent that you have through the problem, through the polynomial. So this would be degree 3. So for instance, 4x to the 3rd, there's my coefficient, and there's my degree on that highest term. Now they're trying to trick you here. We're out of order, and we need to be in descending order. So yeah, it's not very helpful. So on that f of x, we should have written it like this. And so the highest degree, so we look at that leading coefficient. The coefficient is -4. The leading term, the coefficient is -4. The degree would be 3. Now this one's in the right order, so the leading coefficient is a 5, and the degree is a 5. This last one is out of order. So the leading coefficient is a -1, and the degree is a 3 from that exponent. Okay, so this is out of order. So I need it in the right order. So the degree here is 6. Leading coefficient is -1. Okay, that was really easy. I just sliced it really basic to just introduce you to the functions. Just hope you understand this is what a polynomial function looks like. You got the leading term. You got, oh well, I guess you should write it like this is what a polynomial function. We go downhill from the highest degree to the least. We don't have any square roots. We don't have any. We don't have a fraction on the bottom. We just have these power functions just added together.